So hi everyone, we have Nick with us here. He's from VoiceRun, and I think he's gonna give better introduction than I will. So I'll give voice to you now.
Awesome. Well, thanks, Peter. I'm pumped to talk to you today. My name is Nick Leonard. I'm the CEO, co-founder of VoiceRun. We are a voice agent development platform based out of Boston, Massachusetts in the States. Relatively early company, but we've had some exciting investors and exciting customers. Spent a lot of time thinking about how you actually put voice agents into production in safe ways, in reliable ways, and it's a lot of work. And so I'm happy to talk to you about what we do and how and the lessons we've learned along the way.
Awesome. So I think what I'm very interested about is how you came up with the concept of running this company and how it evolved over time.
Yeah, so my co-founder Derek and I, we've been in the voice agent space for maybe 5 or 6 years. When we first started out, it was at a company local to Boston called Posh AI, and they do they do all modalities, chat, voice, different modalities of AI interactions for banks and credit unions here in the U.S. And so that ended up being a bit of our proving ground for understanding what's required to really go to production with an enterprise. It's a lot different than like an NPC in a video game, right? Like there's a different reliability required. And so we spent time doing that. And that was kind of pre the emergence of LLMs, right? And so when LLMs come out and emerge, it's clear there's going to be this new paradigm of how voice agents are built. And so we wanted to be a part of that. And so we started VoiceRun, and we name it VoiceRun. We're partly inspired by Google's Cloud Run product. If you're a developer out there and you're familiar with serverless infrastructure, event-driven paradigms, that's how VoiceRun got started. We're a serverless paradigm. People deploy to VoiceRun. They don't have to worry about scaling. Everything's event-driven. So text events flow. Transcription events. We'll talk more about that. But like transcription events come into our handler. It's going to process through some arbitrary code that our clients own, that we run. We sandbox safely. Events are yielded out of that. Some of those might become speech that we send back to the user. Some of them might interact with digital systems. That's how it was really my co-founder's genius to be like, this is actually the way that systems should be architected. I think implicit in that is this idea I mentioned that when people deploy to our platform, we are running their arbitrary code. And that's the big unlock, and I think why VoiceRun is onto something special. Voice agents that are done in no-code solutions, they're never going to make it. Like, that's my take. Yeah. I'll say it here, I'll say it forever. If you're designing a voice agent and you're drawing boxes on a screen with little arrows, like, your voice agent is not going to be ready. You might get it, you might sell it because someone might buy your demo, but at the end of the day, it's going to have lots of problems in production. It's going to drive your team crazy, and it's going to disappoint your customers. And eventually you will migrate to a code solution, whether you self-host that on your own servers, and then your audio runtime is communicating with your software, or you deploy on a product like VoiceRun or some of the others out there like LiveKit. You've got to be in code. And so that's a lot of the origin of VoiceRun. Is we came out of enterprises in regulated industries like banks. LLMs emerge. We realized there's a new way that we need to develop voice agents. It has to be code first. And so our way to make that really simple for developers is to operate in this serverless event-driven paradigm and run their code arbitrarily on our servers.
Yeah, makes total sense. So what got me particularly interested when I looked at your website is that I see that a lot of the offering is essentially we help you integrate everything with our forward deployed engineer. Yeah. So can you tell me a little bit more about that? Because I think it's quite unique approach on the market, and I have quite a lot of opinions on that, but I'm really curious how it started, and it's just super interesting to me.
Yeah, happy to explain it. So, so at the end of the day, to successfully run on VoiceRun, there will be some form of configuration, which can be infrastructure as code, as well as a handler. It's probably going to be anywhere between 500 to 5,000 lines of Python. That's going to determine all the business logic of your voice agent. Now the hard part is going from how do we actually get that out into production and get it good. And there's two different approaches, and we support both. So one is if you're an independent developer out there, you just want to sign up for our platform and play around and build, you're welcome to do that. The one that's both more lucrative for the business, but also what feels just to be a larger demand in the ecosystem today is there are enterprises that understand that voice agents could be very powerful for them, but they don't have the skills in-house yet to build a voice agent. And so when I think about building the voice agent, that's, we simplify it a lot by taking care of the audio runtime, by orchestrating between model providers and making that just like one-click configuration. But at the end of the day, that business logic is going to be encapsulated in some form. All that business logic, that handler is going to encapsulate the UX that your user is going to experience. Most engineers today and most designers today have a career building visual UX, right? Like it's a screen or it's a phone and I'm interacting with it.
Yeah.
Voice UX is really different. It's low bandwidth, right? It's like, people are talking at 150 words per minute. That's about tops. And you're not getting any visual component, at least over the phone. There's some hybrid systems, but for most cases, you're not. And so if you think about when you look at a Amazon page, you can see 50 products on the screen at one time. If you were to go through those 50 products and I'm going to talk you through them, I'm going to use all kinds of different things, right? Like I'm not going to describe them one by one. That's a really inefficient algorithm. I'm going to kind of categorize them mentally and then describe them. I'm going to it's a whole different process. And so voice UX is like a whole monster of its own. And so because of that, because we're bringing a new technology, a new platform, and we're bringing it into a new UX paradigm, the enterprises we work with often want help. And so is to help them. And we will forward deploy our engineers who will build the handler for them, will use all of our tooling that we've built to make it easier and faster. And we'll do it hand in hand with them so that they learn on the job from us and we can accelerate their voice agent development. And we're very incentivized to do that. Like most voice agent platforms like ours, they meter their pricing, right? So you charge some kind of per minute fee. And so for us, it's like very much in our incentives. We want to be handling more traffic for them. They want us to be, because we're often lower cost for them and often better outcomes for their customers. And so everyone's incentivized to get this thing up and scaled. We just happen to have the skill set to do it on day one. And so the fastest way is if we forward deploy and work with our clients directly.
Yeah, that's what I imagine. I'm asking because essentially what I'm doing is very similar to what you're doing.
Okay.
I mainly focus on helping companies to strategize about what to implement, why to implement it, where are the low-hanging fruits, and how to go about doing it. And I feel like it's the only way for bigger companies because the typical way that people approach voice AI is they hear about SCT, TTS, LLM, and so on and so forth. They're like, that's a lot of things. So I'm going to use Vapi or any other platform really that simplifies the whole thing. They invest about 2-3 months, maybe a little bit more. Then they realize that it's just a little bit difficult to get everything set up through these platforms. And then they start learning Pipecat probably. And first 6 months or even more sometimes is really just an exploration of the different configurations, what is possible. And then you still have a product to build after half a year. This is at least my experience with various different companies. And I haven't even touched on what you said, which is voice UX, which is like, it's just a lot of different things.
Yeah.
So I completely agree with you that it is, it's just super difficult to get started in my opinion, and it helps you speed up the whole process a lot. So this is super interesting. And I suppose, like, I'm curious, how does it help you shape the product? So obviously it goes hand in hand, and it's interesting to see that. If you could tell me a little bit more about that.
Yeah. Well, we are, it's a developer platform, right? And so then when we're the ones being the developers to develop on it, yeah, it's so great. It's like we're not dog fooding our own product. Like we have to use it. We have like more than dog fooding. It's like actually how we get our work done. And so it's been really, really helpful because then you're building tooling for yourself that becomes the product, right? And so it's been awesome. Like the past 4 or 5 months, especially. I mean, anyone who's developing using coding agents is just feeling it. Like the acceleration is so fast. And so today, most of the handlers that we write for a customer, like I don't write that code, like Claude Code writes it, or now Codex writes it. And that then it impacts, okay, well, if I want Claude Code to write it, or Codex or Cursor, whoever, I need to build the tooling layer so that those tools have access to all the information they might need, right? And so, today, when we have if we were two AIs having a conversation, and and we had the session log from on voice run, the session log has a handful of things. So it has like transcripts, that's table stakes. It has event logs because it's a Python handler, so like you have all of the logging that you're doing in there accessible. You have traces, right? Every API call you make, whether that's to an LLM, whether that's to another system, like you have the trace of that. You have the audio recording, and that's like, those are all the things that I would use if I'm just going to debug a session on my own. And what's amazing is you can just feed all of those things straight into, Claude Code or Codex or whatever. And they can do a pretty good job of interpreting what went wrong. And because voice agents on voice run are built in just a Python handler, they're pretty good at fixing it too. Right. And so what we've done, over the past 4 months, that I imagine we wouldn't have done it if we weren't forward deployed engineers working on our product. It would have been a really long feedback cycle to get this. But because we're doing it, because we're the ones building these agents, it became obvious. Every part of our platform needs to be code, not just the handler, but all the infrastructure needs to be like Terraform, like infrastructure as code, and everything has to be CLI native. And so what we spend most of our time on is like documentation, the voice run CLI tool, and then making sure that just the tooling is improving. And so, I think that's what's really exciting, what I'm like really proud of what we're doing right now. And, to answer your question, which is like, those are the insights that we only got because we're the ones out in the field building voice agents for these enterprises. And then just, we're lazy. We want to make our lives easier. And so then now we built this tooling layer that now, Codex and Claude Code and Cursor can consume, and they're way more productive than we are.
Yeah, makes sense. So what do you think was the biggest challenge? Because I know that the scale that you have is insane. So I'm really curious about this topic.
I mean, there's the underlying infrastructure is obviously like not to be underestimated. As infrastructure grows, it's really easy to have latency bottlenecks, right? Like if you proxy LLM calls because you want to be able to track token usage, now your proxy needs to also be like horizontally scaling, and like like any little hiccup is very noticeable in voice. So there's the infrastructure challenges, but I think the hardest part has been realizing, one of the things you said at the beginning that I totally agree with is that building voice agents is like it's very complex and people don't have a lot of practice with it. But I think what's interesting is like, say you're pretty well versed at this point of like how to build voice agents, what platforms to use, how to go about it. I think I'm pretty versed at it too. But when you go work with an enterprise, it's not like we're not inherently knowledgeable about how their systems work today. And particularly when you're doing a call center transformation, when you're working with a big insurance company doing some kind of transformation for their call center, it's complex. Like, we have one client. You call them, the first thing you enter is like a IVR DTMF menu. Press 1, press 2, press 3. There's 74 nodes. Okay, so it's 10 digits, 74 nodes. It's at least like, and it's not perfect. So it's not like only 2 layers deep. It's like 3 to 4 layers deep at times, right? And so when you start thinking about how do we execute on an AI transformation for that type of organization, the first step's pretty easy. We're going to get rid of 74 nodes and we're just going to have a voice agent route. That part is pretty easy. But then you've got to understand behind each of those nodes, what can AI do today? There might be some things that really you still need the humans to do. What system access is required? What is the business logic that's in there? And then you're going to do this, okay, well, we can replace all 74 nodes, but then you're like, well, actually, that's just a weird construct of the way human staffing was. And actually, we can combine some of these nodes because there was like an English-Spanish line that did the same thing. So we're going to put those together now. And it's like, holy crap. Like, you want to understand how this call center has been built over decades, staffing all these people, and some of it's outsourced, some of it's insourced. Like, these things are incredibly complex. So before you even talk about AI and voice agents and like streaming audio, it's like, you got to understand this system. It's crazy. So anyway, I think everyone like sleeps on the fact that like, oh, it's very easy. Look at this demo I made you. And it's like, look, I don't even understand, as a human, I don't understand how this system works.
Yeah, for me, I have very similar experiences. For me, one like super crazy one was that we needed to get data from on-premise database, and taking data from it takes around 10 seconds, right? So you have to do it via only this database. So imagine like, okay, let me just check it for you, and then 10 seconds, like, blank silence, right? Because it tries to fetch the data that is somewhere, and the database is terribly slow, right? So you find those things that are not working in the organization, then and like you have to translate it onto the whole experience, because if you don't, then like users are gonna hang up, everything's gonna fail. And also for me, a very funny thing to experience was like call transferring. When company didn't have enough agents and they thought they did, so the experience was, let me transfer you to a human agent, and the call drops because nobody is here to pick it up, right? So like,
yeah. Well, I think what's so interesting, you said one of the worst things that can happen is that 10-second gap, someone hangs up. But it's like, even worse, we could go into it, but it's like even worse than maybe hanging up is they start talking, right? They're like, oh, hey, are you still there? Because interruption handling is by far like the hardest part of any voice system today. It's like, when do you allow it? When do you not? What are the rules? And so, I think a lot of the, obviously everyone focuses on latency, and latency is important, but I think one of the, the latency is really important, obviously, because you want a good, nice conversation, but it's also because if you have high latency, people get confused and then they talk again, and it's you don't really want to have a system that you can't interrupt it. That just feels like 2005. And so you want to be able to smartly be interrupted and things, but then if you have high latency and you allow interruptions, oh my god, you're going to get in these loops. There's all this pain, and I can only imagine, when you're working with a 10-second a 10-second API call to the on-prem system, you basically need to put them on hold and play some music. Like, it's tough.
Yeah, in this particular scenario, it's just a digression, but in this particular scenario, the fix, let's call it, was to make it a async call, and in the meantime, ask for another question. So ask the first question that has this huge latency, then ask other ones, so user has no idea what's happening, right? But without us understanding what's going on underneath the system, then it's impossible to solve this issue, right? It's like those little things. Yeah, go ahead.
Oh, I was saying, like, this is a great example of like why I led with, you can't build on no code tools, right?
Yeah,
like, exactly. You needed an async process, like no code tools. Maybe they support it in some way, but if so, it's in the narrowest way ever. Like, you needed to be in code. We have a concept on our handler called background tasks, but same thing, runs asynchronous to the kind of flow of the conversation. Great solve. Good job. That's a great way to solve it.
Yeah, and that's why I think this space is so interesting. And I feel like a lot of the time, because you mentioned something that's also very intriguing to me, I hear a lot of conversations about latency, but I feel like it's a term you just staple everywhere, and it means 1,000 different things, right? So you have you obviously like have latency, that it takes quite a while for the agent to get back to you, but you have perceived latency, so something can really last a lot of time, but your agent can be saying like, all right, let me check it in the system, and it already takes 3 seconds, right? So a lot of the ground has been covered, and the person doesn't feel that bad about it, right? So I'm curious, do you have similar situations like from your like certain hacks or clever ways to help it for users not feel this latency?
Yeah, and before I answer, I'll even say, I think the other thing people sleep on with latency is like it's a multi-part system. And so if you get a win over here, you can be more precise over here, right? And so or you can be more conservative over here. So like, for example, if you're using some kind of like energy-based model to do VAD turn detection, like Solaro, you can endpoint after 300 milliseconds, or you can endpoint after 900 milliseconds, right? And 900 milliseconds is going to be wrong a lot less than 300 milliseconds. But obviously it's going to add 600 milliseconds of latency in most cases. And so the question is like, well, what do you have after that? If what you have after that is only 100 milliseconds, then like, great, use the 900 milliseconds. But if what you have after that's going to take a long time, then you need to use the shorter one. And like, that is like, people don't even, it's not just necessarily latency wins. It's sometimes by being really good in this part of the system, you can be worse elsewhere. If you have really good, perfect interruption handling system, then you can put your endpointing at 100 milliseconds and then, you trust your system to handle it. And then you can have a slower LLM call or whatever it might be. So I think that's what a lot of people sleep on, is that like having faster latency in pieces allows you to be slower elsewhere and still deliver good experience. I'll give you a hot take. You said, do you have any hacks? Here's my hack for you, for anyone. If you're using a state machine, this is, again, can't you do it? No code tools, they don't work. You can't do this. But for code, don't go to the LLM if you don't have to. That's my take. And so I'll tell you what I mean. Super common question on a phone call, at least in the United States with our regulations, is if we get disconnected, is it okay if I call you back? People ask that every call. Call centers they'll ask that question hundreds of thousands of times a month or a day. Well, guess what the answer is? Yes, no, that's fine, it's okay, sure, that's fine. You can enumerate out all of the answers. You can enumerate all of them out. You normalize it, strip the punctuation, lowercase it, get rid of spaces, and now you should literally be exact string matching. Exact string match that, and that process costs you 900 nanoseconds. And the 10% of the time where you don't match, fall back to the LLM. And you can do that across a ton of use cases. It's actually crazy, right? Like if I said, we were scheduling this conversation, we went back and forth, and you said, what time works for you? You can enumerate out 3 o'clock, 3:15. You can just enumerate these out into these large maps of 1,000 enumerations, because Claude Code and Codex will write out 1,000 enumerations for you. And if you're really good, you actually give Claude Code and Codex access to your transcripts, and then every day it can add to the enumeration list. And at most it's going to cost you a millisecond, or maybe 1.5 milliseconds if your dictionary gets really big. And now you've cut out the LLM entirely. You're saving on cost. You're saving 700 millisecond round trip time. And like 700 milliseconds is a ton in voice. So anyway, that's my hack. It doesn't work for everything. If you have a therapist app that has nothing that's deterministic, or something where like a state machine doesn't make sense, then like you really can't do it. But in a lot of like a surprising amount of enterprise use cases, you can do that, and it's wild. You cut out, like you get to the point where you can cut out the LLM call entirely. You should definitely cache the audio if you're using, text to speech, 11 Labs, Cartesia, whoever you might be using. Cache that audio if you're going to reuse it. So now you can imagine a system where user stops speaking. If you're using a really good semantic VAD, sometimes you'll get endpoints that are like 250 milliseconds after they're done talking. You can literally done 250 milliseconds later, you've endpointed, data's transferred to our system. We've processed through the handler. We've realized it's an exact match. That's 2 milliseconds. We've gone to get the speech back to you. we go to our Redis, we pull the audio from cache, we stream it back to you. We can have like, it is possible in some cases to have like sub 300 millisecond latency, just by chopping pieces out, right? You've basically chopped the LLM, you've chopped the TTS.
Yeah.
And that's what like real production grade stuff looks like. You have to be careful, but that's why I use exact string match and not like regex. Regex, suddenly you get in weird spots where you can like misfire. But if you're just exact string matching in a state machine where you like know the state you're in, like it's pretty safe.
Yeah,
that's my fun fact. That's my fun hack.
It is very interesting. I think it especially works well with larger companies where the questions typically can be like yes, no, etc. Right?
Yeah.
And yeah, I think it's super cool. I think I heard once or twice about something similar. I haven't used it myself, but very cool tip. Thanks for sharing.
Yeah, no worries. That's my favorite hack out there for people. You save a lot of money, you save a lot of latency, and it's dependable. It's not like it's not like there's a big trade-off here, right? Like a lot of times people get in these systems where they're designing and they're saying, well, we'll run a lightweight LLM and then we'll route to different larger LLMs after, and now you're paying this latency cost on every turn. With the exact string match, the latency latency penalty is like 1 millisecond. Like who cares? It's fine. So yeah, that's my favorite.
Yeah, I really like it. Yeah, it's one of the things that interests me quite a lot. So depending on the industry that you're working with and the exact job that the agent is supposed to do, you quite often get completely different architectures, right? So I've heard that I had clients who had a small agent and the background agent, larger one that actually does all of the heavy lifting, and it makes sense for complex cases, right? And many different ones. I actually plan to make a video on that. I think your example is super cool because given the amount of these conversations that the enterprises have, this is super useful. Awesome. Love it.
Yeah, I think one of the other architectures that gets really interesting is, particularly like we see in like food ordering use cases. Like if you call a restaurant and want to pick up food, like these menus, like people forget how large a menu is. It's so big. It's like a megabyte of text. It's like, because everything has modifiers that can be included and like upsell instructions and all these things. And so what's interesting is like when you're working with a food ordering platform, the menu is also dynamic, right? Time of day can change. They can run out of ingredients. So it has to be like live. You can't cache it in any way. And so your LLM sometimes you'll actually be like exploring the API almost like a tree, where it's like they asked for, pasta. I don't know. They asked for pasta. You reach out to the API. You say, oh, what are the modifiers of pasta? And you're like looking. You're like, oh, I can get like red sauce or white sauce. And then you're like, okay, user, do I want red sauce or white sauce? And then you're working your way through it. And it's like that's even an interesting architecture where you're kind of like, it's like you're kind of doing this like tree exploration and then like getting back to the user. It's a whole different thing. And that one looks a lot more like the way that Claude Code or Codex uses like the CLI, where they're just like hitting tool calls all the time. But yeah, now there's a bunch of different architectures, and I think that's again another reason why at this point in the industry's like maturity, I think forward deployed engineers make a lot of sense, because you got to pick the right one for you and be able to explore and build them faster, and that helps a lot.
Yeah, I think what you mentioned is something I've seen literally 2 days ago or 3 days ago at AI Thinkers conference in Poland. So a company was building an agent for car tires essentially, and literally traversing the tree with the different options. That being said, the experience overall for the customers is still quite painful because it is a tool call every single time. So I think we're still like, I'm just guessing, but a year or maybe a little bit less, I don't know, from like better experiences with LLMs in the shopping area, because it's still kind of clunky, but it is super
Retail's
cool from an
hard.
engineering perspective.
Shopping is really hard. I think I think you're right. I think it's gonna be one of the last ones to go. It's like such a massive tree. Like you go to a retail store online and try to explore the options. Ugh, it's so hard.
And it's also like, you typically don't buy things over the phone, right? You don't really
Right.
what shoes would you recommend? It's like, it's not what we do even as a humans, and we'd be much better than the LLMs, right? And we a lot of people would like an LLM to do it because it's a really cool concept, but if you think about it, it's also incredibly difficult, right? To get it done. So I think it has lots of cool applications, but in very specific sectors. So I think it's also an interesting approach.
Not to go too deep here, but like I think you can think through analogs of like kind of like, what do rich people do? And I think one of the things on like shopping for clothes, right? Like there are stylists that if you have a lot of money, you can call a stylist and they'll talk to you and they'll ask you all these questions about what kind of clothes do you like? What kind of things do you like? What are the activities you're going to be doing? They do all of that and then they show you the clothes, right? It's like the voice is only just to like build the algorithm of what could be good for you. But then they go get the clothes, they bring you into the studio, you look at them, you try some on, right? And it's like, I don't see voice agents doing, like, at least not over the phone, right? Maybe we get to some multimodal where we're like generating pictures while we talk to you. That could be interesting, but that's far out. I mean, not that far out. Like nothing's far out right now, but like it's farther out than other things.
That's true. Yeah. An interesting take. I had exactly the same thoughts, so that's cool. Okay, I'm also really curious, like, how do you generally work with your clients? Because I know that obviously you get like benefit from the fact that they succeed. Do you know any numbers on like typical ROI for your clients? How much do they actually gain from using your product? Because I can imagine the savings might be huge.
Yeah. So there's like, I think that, and this is also challenging, right? It's like if we think through that same question and we think through other UX paradigms, it's very difficult to describe to someone like, how much does your website, like, how much ROI do you have from a website? It's like, oh, I don't know. It's like some websites make you money, some of them save you money, some of them just give good feels, right? And so I will answer the question the best I can, but I will say it really depends on the use case, right? Some use cases are cost reduction, right? Like we pay X, we would rather pay Y. People building with voice agents, ours and others, can save like 90%, right? Like especially in the US where labor costs are high, and I know parts of Europe where like labor costs are particularly high. You're oftentimes paying all in once you include like benefits and all these other things. Like at least in the US, it's like maybe $25 to $30 an hour. And you can run a voice agent easily at $3 to $4 an hour. And so it's like, that's a 90% savings basically right there. So like that's on the cost side. That's on the hourly cost side. Now, what's interesting about it is also you have this like horizontal scaling, right? When you employ a human, they're not on the phone all the time. Or if they're on the phone all the time, it means you maintain a large hold queue, but likely they're only on the phone 50 to 75% of the time. But your agents you're only getting billed for a voice agent when it's on the phone. So you save a lot of money that way too. So there's the cost reduction. There's often a lot of like revenue, like we can do a lot of revenue generation. A lot of the clients that build on Voice Run are building revenue generating voice products. And I think the reason for that is once you're generating revenue, like when you're just trying to reduce cost, you're sometimes willing to offer your customers a worse experience if it saves you enough money, right? This is why BPOs exist and like offshore customer service. You're like, well, I know it's a marginally worse experience for my customers, but it's way cheaper for me, so I do it. When it comes to revenue generating things, people are not willing to make that trade-off. And so I think having like a code first development canvas, like what we have, allows the extensibility to build something that's, equal or better than their in-person agents. And so we have one place that's a revenue generating call center. We're partway through the transformation, but they've reduced their team size by 40%. They've increased their call volume by 25%, and they've increased their revenue per call by 20%. And so you kind of combine all those things up. It's like all three factors of the business that matter to them: their top line volume, their cost per call, and their revenue per call. And so that all ends up being an impact. On the other side of the equation, on the other side, we work with like a tech company that is like it's like a reservation platform. So like if a restaurant needs to have reservations, they've been traditionally a reservation platform for, phone-based like app, online on a website or in-app reservations. And they want to build a voice product. They want to sell to their restaurants and have the phone line because they notice there's a lot of startups trying to do this. And they noticed that some of their other competitors in the reservation space were offering this as a feature. And so they needed to compete. So they built that on us. And so the ROI for them, it's like, this is an entire new capability that they couldn't offer without us. And so that's what's like a really exciting thing. That's slightly harder to answer on like, what's the ROI?
Yeah. I mean, I completely agree. At the same time, I think, generally speaking, my wife is doing something in the kitchen. Generally speaking, I think it's oftentimes it's difficult to calculate it that way because some agents also perform actions like strictly simplifying the work and not really replacing humans. You may employ same amount of humans, but really cut through the tickets faster to improve customer satisfaction scores, right? So I completely get where you're coming from, but I think it also sheds the light on what you can achieve with it, right? Because there are already companies doing it. There are companies that do it well, and at the same time, I think it's very crucial to have somebody on board who knows how to do it, because you can easily shoot yourself in the foot if you just let's replace all of our agents with AI. It's not a good idea.
No, you're gonna have a bad time. Don't do it, please don't do this. Yes, no, you're totally right. And I think that's, I think before we started recording, you were mentioning like how frustrating like the voice AI industry, we're like very bad offenders of selling this hype. It's like, it's easy, plug and play, and it's gonna work. And then so it's very, I think, frustrating when you're one of these, customers with this great voice use case, and you're like, wow, AI is moving so fast. Dario says 50% of software engineers are gonna be out of a job in a year. This must be true. Give me that voice agent, and then it bombs, right? And it's just not able to do what you want. And then you're like, oh, let me go build it myself. And now you're doing that, and it's death by 1,000 cuts. And the reality is there's just not enough people like you and me to serve all the people and help them on this journey, right? And that's why it's like why we're working all the time, is because there's so many people who just need to be taken on the journey of like, what's it going to take to make my voice agent real? And for us to be able to do that, we have to go then and understand their business, because like we said, every business is different, and you're probably going to build it out piece by piece, so it's tough.
Yeah, it is a process. Like it's not possible to like, okay, you have to do this. So like you had to hire somebody to just no, it's complex. Yeah, I think it's really interesting, especially to hear it from you on such scale, because it mimics my experiences so much.
But I will say, I do think there's going to be a place where building these are going to be dramatically easier. And so what we see today, is, I kind of described this loop that happens on Voice Run today, right? Which is you have a bunch of calls. If you're my customer, you have a bunch of calls today. Tonight, we have integrated evals that are going to identify all of the unsuccessful calls. All of those calls are flagged to us. Our systems we're not a model company, but so we're using the same Opus 4.7 and 5.5 Coda, GPT 5.5 that everyone else is, but they're going to be pulling down all the data, right, from that call. They're going to have the code that includes all the business logic of what that agent was supposed to do. And they're going to be able to like push, they require approval, but they're going to push fixes. They're going to create PRs for fixes. And when we come in the morning, we review them. We're like, oh, okay, this fix, this fix, this fix. Reject those 3 fixes. And like, that's the end-to-end loop today. But where we are going is to inject ourselves at the audio transport layer for even the human to human calls, right? So like someone has a call center today, we're getting in to be the audio transport layer for those, just like a SIP trunk kind of thing. And then once we have those recordings, we have those transcripts, right? And now we can apply that same kind of end-to-end learning loop to proactively build out people's voice agents just from like passive listening. We're not there yet, but I do think like this year in 2026, like that type of system will be able to, like, once we integrate in, we can extract all of the good UX from the best practices that VoiceRun publishes and the skills that we have from the actual interactions that, you know, human agents have with customers, and from just kind of like the implicit knowledge that exists within these models. Like, I think we'll be able to put out really good voice agents nearly autonomously, not to add to the hype, because I don't think we're there, but I don't think we're far from that world.
I think it's super cool. One of the things that I actually did for my clients was I asked how many people from actual call center were involved into making the system, and they were like, none. What do you mean? Like, oh my god, you're making
you're gonna have a bad
call
time.
center agent, and we don't have a call center agent in here. Like, it's bad, right? So I really like the concept. I'm very curious to see it in action when it's gonna be there.
I'm not saying it's done yet, because I'm not one of those hype AI people, but I think we'll get there. I think we're gonna get there this year.
Yeah, I think it generally speaking, the issue I'm having with let's call it autonomous feedback loops for AI agents is that what LLMs love to do is they take a failed call, look at what's there, and they're like, okay, this is a fix. And while fixing it, they break 3 other things because they didn't hear other 4 or 5 calls in which everything was fine with this prompt, right? And it caused the regression. So I'm thinking that potentially in the future also some additional like graph relationships between the calls, something like that may be necessary. I'm just throwing ideas for your team as well, by the way.
Appreciate it. Yeah, the 2 things that we think about are, you know, we do have like a simulations product where we're like agents call agents, you know, just to like generate synthetic data that can help serve as kind of like regression testing, like you're saying. And I think the other thing is like, you can kind of identify, this is tricky, but like turns of an individual conversation, you can identify them as like golden tests, right? So you take a turn of a conversation, you know the state of the conversation in that moment, and then you can take like that 8 seconds, and then you can play it at your new agent and see how it would have handled it, and does it handle it the right way. And you can identify like what are your test set that you care about. Like, these are the 20 cases we want to run against every new version of the voice agent we deploy. That's another decent way. Unfortunately, you can't just play the same audio all the way through. Obviously, you can only do like one turn at a time because the calls would diverge. But those are some of the things that we try to help people make these, because it's tough.
Definitely observability, understanding how the system works, probably having somebody, you know, skilled. All of these are like super important. I really enjoyed you know, talking to you about these things. I think I'd like some kind of wrap up for this, because I think you have a lot of very valuable insights. So I suppose my last question would be, if you were to recommend something to enterprises today when they're integrating voice AI, how would you recommend making this first step?
Well, I think talking to you is a great option for them. They should talk to someone who's built these systems. Let me plug Peter for everyone right here. You can come talk to VoiceRun too, but you should talk to Peter. You know, I think the big gotchas that I see out there is like, you know, you should understand that it's not going to be done in a day, even if the demo comes in a day.
Yeah.
I think the 2 things that I would recommend, or I'll give you 3. The third one is the spiciest take. So the first one I would say is, don't tie yourself to a model, right? So like,
Sure.
I love 11 Labs as like they're a vendor to us. We use their text to speech. We use their speech to text. We support both. But if you're going to build an agent with them, they're going to want you to use their models, and that goes for every model provider out there. All of the audio models provide some kind of agent platform. I wouldn't do it. If someone else is better, you want to be able to go to the best model, right? So we are one of many providers out there that orchestrate between different models. So definitely that'd be my first kind of gotcha I would look out for. The second one is no code. Stay away from no code. Stay away from no code builders. Like, you might build a cool demo, but there is a ceiling for how good those systems can get, and you will find it fast. It kind of goes back to like Andre Karpathy's. He talks about when he talks about Tesla autonomous driving, every 9 is the same amount of work, right? So it's like 0 to 90 is a lot of work, 90 to 99 is a lot of work, 99 to 99.9 is a lot of work. And these systems are absolutely the same in the sense that it's maybe even more work to get the reliability as you go up. But if you have a no-code tool, you'll never even get there. Like 90's your ceiling, good luck. And then my third one, my spiciest take is that, like, beware with speech to speech. We didn't talk about it at all. I'm amazed when I talk to a speech to speech. It feels amazing. I love it. I would never put it into an enterprise. Like, maybe for like a therapy app, maybe for like a low stakes customer support where there's no integration into another system. But speech to speech it's expensive. It's unreliable. It's sometimes offensive. Like, if you hear it speak other languages other than English, sometimes it just sounds like some American speaking that language, and it's kind of rude. like I don't recommend it. And you don't have control, right? Like, your only tuning is the system prompt, and you're going to run into this thing where the system prompt's going to grow really big. You're going to make a change here, and you're going to have a regression there. And so the ceiling, despite how natural it feels, the ceiling there is still much lower than a cascaded system that has a code intelligence later. So those are I would just say is like, don't go to an agent platform that is also a model provider. Oh my God, what was my second one? That's my first one. My second one is you got to be in code. And my third one is kind of a corollary to that. It's like speech to speech, just it's not there yet. It probably will get there someday, but it will always be more expensive and less controllable.
Yeah, I feel like every single advice, like, just use this, it's gonna solve your issues, it's probably a lie. It's probably not like that.
Probably.
Okay. Awesome. I love having you here. I'm gonna put the link down below the video so that everyone can see your platform. I think it was a blast talking to you, and I do value the offer that you guys have. I think it's super interesting approach, and I think it's absolutely necessary for enterprises to have somebody working with them and not really just offering the platform. That's it. Awesome.
Yeah. Well, thank you so much for having me, Peter. I really appreciate it. And I love talking to other experts in voice. If you're someone out there and you're watching Peter's work here, also like it, comment, all that stuff. But also, if you come to Voice Run, and just let us know if you came because of this, and we'll make sure to give you some credits and let you play around for free. We look forward to having you on the platform.
Thanks, Nick.
Awesome. Thank you, Peter. Bye.
All right.